and this lecture is over forest resources. When Jean Robert was a young boy, the mountains surrounding the Haitian city of Renauvet were still lush and green with trees, and his family's hillside farm produced a variety of crops. But today, the forests are gone and the mountains are bare. Besides crop yields having shrunk drastically, the mountain homes in the city below have been left defenseless against the tropical storms that pound Haiti every summer. Unencumbered by trunks or roots or shrubs, water rushes freely downward, gathering into apocalyptic mudslides that destroy homes, crops, and livelihoods. In 2004, a single storm claimed more than 2,000 lives from this one city. Now, Robert and his neighbors are trying to bring back trees. Working as a team, the community work group plants a carefully planned mix of fruit and timber trees. By the end of the month, they say, each member will have his or her own saplings to tend. If the saplings survive, their efforts will give rise to a new era of sustainable forestry which strikes a balance between what people need from the forest and what the forest itself needs to survive. The community work group will plant 3 main types of trees. They start with fast-growing multi-purpose trees like the moringa. Because it is a nitrogen-fixing plant, the moringa helps fertilize the soil. And because it grows quickly, it can provide a sustainable source of food. The leaves are edible and fuel wood. Next, they plant fruit trees, mangoes, avocados, and citrus. These trees take longer, about 3 to 5 years, before the fruit is ready to harvest, but they put down roots and thus stabilize the soil in just a few months' time. The last thing the community work group will plant are the slow-growing timber trees, which may be sustainably and profitably harvested in the future, but don't provide any immediate benefits to farmers today. But to really understand how trees might help alleviate poverty and protect communities, we must first consider just what forests are, what they do for us, and why so many of them are being chopped down in the first place. And that brings us to key concept number 1. The location and characteristics of forest biomes are influenced by temperature and precipitation, giving rise to the main 3 forest types: boreal, temperate, and tropical, and a variety of subtypes of each. So forests are biomes dominated by trees. They currently cover about 25% of the planet's landmass, but thanks to their sheer concentration of biodiversity, they are home to more than 50% of Earth's terrestrial life and more than 60% of its green photosynthesizing leaves. There are many types of forest biomes around the globe, each determined by the temperature and amount of precipitation that they receive. So boreal forests are characterized by evergreen coniferous, that is cone-bearing trees with needle-like or scale-like leaves, species like pine, spruce, and fir. They cover vast tracts of land in the higher latitudes and altitudes and are characterized by low temperatures and precipitation levels. They represent some of the most expansive forests left on Earth. Some of these stands are still primary or old-growth forests. Other areas that are harvested for timber have regrown as secondary forests. Temperate forests, which contain deciduous trees, that is, trees that shed leaves seasonally, broadleaf trees like oak, hickory, and maple that lose their leaves in the winter, are found in the mid-latitudes. Evergreen broadleaf trees like the southern magnolia are found in warmer regions of these latitudes. These forests are not as expansive as the boreal forests because they are found in latitudes with high human populations. Most temperate forests today represent secondary growth rather than primary stands due to extensive timber harvesting. However, some areas have seen remarkable regrowth in the 20th century. For example, there is now more forest cover in the eastern United States than there was in the 19th century following heavy clearing. This regrowth can be sustained because forests elsewhere are harvested. Tropical forests contain a diverse mix of tree and underground species that are found in tropical latitudes where temperatures do not vary much throughout the year. Though vast tracts of primary tropical forests still remain, these forests are experiencing the highest losses of any forest biome, especially in Southeast Asia and South America. So when European settlers first arrived in Haiti some 500 years ago, 2/3 of the land was covered in forests so majestic that the explorers dubbed this region the Pearl of the Antilles. But as centuries passed, the forests were cleared, sometimes with amazing breadth, to make way for coffee and sugar plantations, and at other times they were cleared in discrete chunks that Haitians would then convert into subsistence farms. Many of the trees, along with the coffee and sugar crops that displaced them, were sold overseas. Most of the rest provided fuel for cooking Haitian meals. In 2018, Temple University researcher Blair Hedges estimated that less than 1% of the original forest remains. 6% of the land has no soil left at all. This isn't to say that Haiti has few trees. As much as 30% of the land area contains trees, but almost all of this is secondary growth existing in small patches. And many of these forest fragments are too small to offer suitable forest habitat for local species. If deforestation continues along its current path, Hedges cautions that Haiti could lose all its primary forest and as many as 83% of the species that depend on it. And that brings us to infographic number 1. Forests are biomes primarily made up of trees and other woody vegetation. There are 3 main types of forest, classified according to climate and many subdivisions within these 3 types. And that brings us to key concept number 2. Forests are stratified, having distinct vertically stacked layers, each of which contains species adapted to the level of sunlight and moisture available. So most forests consist of 4 distinct layers. The canopy, which is formed by the overlapping crowns of the tallest trees, makes up the ceiling of the forest. In some cases, an even taller tree may reach above the canopy as part of an emergent layer. Beneath the canopy is the understory layer, where shade-tolerant shrubs and smaller trees or saplings of larger trees grow. Sometimes these trees are dense enough to form a lower canopy. The lowest level is the forest floor, which is typically made up of seedlings, herbs, wildflowers, and ferns. The forest floor also contains soil, which is composed of leaf litter and other debris, branches, logs, and stumps that decompose over time. Within each forest layer is a range of species uniquely suited to the temperature, humidity, and amount of sunlight reaching that layer. Species well adapted to their particular neighbors. For instance, in a temperate deciduous forest, wildflowers on the forest floor will bloom early in the spring before the bigger trees leaf out and block the sun. Sunlight is a precious commodity on the forest floor, and wildflowers compete for it. One wildflower species may bloom one week and another the next week. Disruption to one part of the forest, for instance, cutting down a tree that opens the canopy, can have a trickle-down effect that impacts each subsequent layer. And that brings us to infographic number 2. A look at the 3-dimensional structure of a forest reveals layers that house distinct species adapted to the environmental conditions in each layer. And that brings us to key concept number 3. Forests provide a wide variety of critical ecological services to water, soil, air, and wildlife, have great economic value. For instance, they provide jobs and consumer products, and provide socio-cultural benefits, for instance, cultural, spiritual, and recreational value. So due in part to unchecked deforestation, Haiti has become both the poorest and the most environmentally degraded country in the Western Hemisphere. With few trees and little soil, drinking water has grown polluted, crops have dwindled, and the people have suffered. Farmers like Jean Robert say that forests are the key to changing all of that. They have planted thousands of trees in the mountainous regions in recent years and hope to plant thousands more. So that is no small feat. Forests, after all, are one of our most contentious resources. Such is the range of ecosystem services they provide that any one must be weighed against a host of others, or they must be weighed against the immediate human needs that are frequently pitted against long-term conservation goals. In Haiti, where most people live on less than $2 a day, trees provide food, energy, building materials, and desperately needed income. To stop them from being chopped down, Haitians will have to find alternative sources of each, not to mention a farming method that doesn't require clearing more forest land. Food, fuel, and building materials are perhaps the most obvious ecosystem services provided by forests. However, even though trees are the largest and most notable life forms present, a forest is much more than just its trees. Together, the species inhabiting the different layers participate in a delicate symphony of chemical and physical cycles that produce an invaluable range of ecosystem services for the planet. It starts with the soil, which the forest itself helps to form and maintain. Leaves and branches fall to the ground and decay, forming a brown layer of nutrients in which all future generations of plant life will take root. While dead and decaying plants help form soil, living ones hold it in place. During rainstorms, roots, especially tree roots, anchor soil in place so that it can't flow as easily down hillsides into nearby surface water, lakes, streams, and oceans with the rain. Soil and roots also slow the flow of rainwater across the ground's surface. This is called storm water runoff, preventing potentially polluted water from reaching surface waters. And by slowing down runoff, a well-vegetated area allows more water to soak into the ground, recharging the groundwater supplies that provide area residents with their major source of drinking water. The soil also traps chemicals that might otherwise contaminate that drinking water. While plants, soil, and water are playing off of one another in this manner, the forest is also conducting another important cycle, pulling carbon dioxide out of the atmosphere and replacing it with oxygen through the process of photosynthesis. Forest leaves provide so much oxygen that they are commonly referred to as the lungs of the planet. But it's the ability of forests to capture atmospheric carbon dioxide that is garnering more and more attention in a world struggling to address climate change. Forests as a whole store more carbon in their biomass, litter, and soil than all carbon in the atmosphere, making this biome the world's largest terrestrial carbon sink. That is, an area that stores more carbon than it releases, such as the standing timber in a forest or organic matter in the soil. In fact, reforestation on a grand scale is seen as a vital tool in the fight against climate change by one calculation. The planting of 1.2 million trees, there are about 3 trillion trees on the planet today, would offset 10 years of human carbon dioxide emissions. The oceans hold more carbon, but their capacity to absorb more may be diminishing. Last but not least, virtually every layer of forest provides food and habitat for a bevy of animals, vertebrates and invertebrates, fungi, and microbes. These creatures all do their part to contribute to the functioning of the forest ecosystem as a whole. It is difficult to overstate the importance of forests to the biosphere. The socio-cultural benefits are also far-reaching. Some people consider forest stands to be sacred, connecting them to their past and representing their future. Many people view a forest as the ideal place to reconnect with nature, become rejuvenated, or find artistic inspiration. Benefits for that, for some, can't be replicated in our modern, built-up world. In addition to all these ecosystem services and socio-cultural benefits, forests also provide a range of economic benefits. In fact, humans have relied on forests for a millennia and for a magnitude of consumer goods. Wood products, including lumber, firewood, charcoal, paper pulp, and some medicines, account for around $100 billion in global trade every year. On top of that, the wildlife supported by forests provides humans with food resources and recreational hunting opportunities. Both have economical value. However, taking advantage of the economic benefits of a forest can lead to its loss and the loss of the ecosystem services it provides. In Haiti, the cost of deforestation spun out over decades and proved catastrophic. Soil eroded into streams, rivers, and gullies, clogging them with sediment and disrupting aquatic ecosystems. With nothing to absorb the water, floods became more severe and groundwater sources were quickly depleted as the water flowed away rather than soaking into the ground. Slowly, crop yields shrank. As the forest habitat was fragmented, biodiversity dwindled. And as the trees vanished, the people of Haiti suffered. Unlike wealthier countries, Haiti could not afford expensive water purification systems, a service the forests provided for free. As time passed, more and more people abandoned the countryside for the capital city. Even that did not stop the tide of deforestation. As the population swelled, so did the demand for fuel, which in Haiti still comes almost exclusively from trees. And that brings us to infographic number 3. This shows the ecosystem services of forests. Moving on, in this second part of infographic 3, we see the estimated annual value of the ecosystem services of forests. And that brings us to key concept number 4. Globally, forest cover is shrinking due largely to harvesting for lumber and fuel, clearing for agriculture or mining, pest infestations, and fire suppression. So over the last 300 years, at least 35% of the world's forests have been lost, many of them cut down for the timber they hold or the land they occupy. Of those forests that remain, more than 80% are degraded. According to the United Nations Food and Agriculture Organization, today global deforestation has slowed from 20 million acres per year to 19 million acres per year between 2010 and 2015. Forest gains between 2010 and 2015 helped offset this loss, resulting in a net decrease of 8.2 million acres. While global deforestation rates have declined in most areas, they are increasing in some tropical areas such as Indonesia and Malaysia. Brazil, where rates had been declining, began experiencing a sharp uptick in deforestation in 2019. Some of our actions intentionally led to the deforestation of tropical and other forests. The most common culprits are the harvesting of forests for wood and wood products and the removal of forests to use the land for other purposes such as agriculture. Growing populations are also spreading out as urban and suburban areas claim forest land. The way we manage fire is also a factor in deforestation, especially temperate forests. Frequent fires remove dead wood and other flammable material. If we suppress these fires, the dead wood builds up so that when a fire does come through, it can burn so hot that it catches the entire forest on fire. Fire is actually needed to maintain some forests whose trees are fire adapted with seeds that germinate only when exposed to the heat of the fire. Climate change is also impacting forests. Warmer winters allow pest populations that would normally die back during the cold months to attack trees year-round, taking a toll on temperate and boreal forests. Though extra atmospheric carbon dioxide, which is a major cause of climate change, and warmer temperatures may extend the growing season in some areas, precipitation declines will negate this benefit in many places. The incidence of fire has also increased, especially in drought-stricken areas. This directly destroys forests, and some may not be able to recover as easily as in years past due to an altered climate. In general, range shifts for many tree species will occur and already are occurring as young trees take root and grow with more success at the highest latitudes and altitudes of their historic range. Trees growing at the lowest latitudes or altitudes in their current range may die out, and the forest may be replaced with a different ecosystem or a different type of forest or even a different biome like shrubland or grassland. So the nature and degree of each of these threats vary by country because forests are often used and managed differently in developing countries than they are in developed ones. As mentioned earlier, the clearing of land to grow crops or raise animals is a major driver of deforestation worldwide. It was no different in Haiti, where deforestation began in earnest with the 18th century French colonizers, coffee and sugar plantations. In addition, as people moved to Port-au-Prince, the nation's densely populated, energy-starved capital city, the city boundaries expanded, claiming some forest land. Population growth also triggered more clearing outside the city to make way for more subsistence crops and to supply charcoal, the major fuel source for the country. Like Haiti, many African nations are experiencing rampant deforestation, much of it to provide charcoal and fuel wood. In Mozambique, for example, charcoal is the main fuel for 80% of the population. More than 2.5 million trees are cut each year in Somalia. That is 10 trees per household per month. In time, Haiti's charcoal trade grew to account for 20% of the rural economy and 80% of the country's energy supply. In most cases, developing countries have far greater remaining forest stands than developed countries, but many of these stands are falling fast in places like Haiti, where dire poverty and a lack of alternatives force people to harvest their forests or remove them from other land uses. They need wood and charcoal for fuel and housing, they need more space for agriculture, and they need commodities to sell in the marketplace. Deforestation rates are lower in many, if not most, developed countries, including the United States, Canada, and most European countries. In these countries, whose early development was fueled in part by clearing their own forests, stringent regulations are now in place to protect these forests that are left, and reforestation efforts have increased forest cover in some areas, including the eastern United States. Unfortunately, any forest gains in these areas are still largely offset by deforestation in developing countries, and that deforestation is often linked to developed countries that are protecting their own forests. Multinational corporations have simply moved deforestation operations to developing nations where regulation and enforcement are often lacking and people are desperate for income. And that brings us to key concept number 5. Selective and shelterwood timber harvesting maximize long-term profits and protect biodiversity. Clear-cutting methods maximize short-term profits at the expense of the local ecosystem. Tree farms are a highly productive alternative that may allow managers to leave natural stands alone. So harvesting forests for timber or other forest products is not something that is going to stop, and there is no reason to expect that it must. There are ways to sustainably use forests. In Haiti, for example, much of the wood now harvested for charcoal production is provided by trimming branches rather than cutting down the entire tree, a method that appears to be sustainable. Of course, there are times when large-scale timber harvesting is needed, and for that, there are a variety of methods that can be used. A commonly used method is known as clear cut, that is, cutting all the trees in a given area. This method maximizes short-term profit, but does so at the expense of the local ecosystem. The forest habitat is gone, at least for a while, and the risk of soil erosion is high, especially if the harvest was done on a slope. Destructive mudslides that invaded Asheville, North Carolina in the early 1900s were the devastating consequence of extensive clear-cutting on the surrounding mountains. This rampant deforestation spurred the establishment of the Great Smoky Mountains National Park to save those mountains from the same fate. Clear-cut areas may be allowed to naturally recede, a slow process made difficult if the soil is lost, or they can be replanted with a single fast-growing species of tree such as southern yellow pine to create a tree farm that may be ready to harvest again in 50 or 60 years. While these forest stands lack the ecological diversity of a nature stand of trees, they can be highly productive and reduce pressure to cut remaining natural forests. However, there must be enough native forests left in the areas suitable for tree farms to avoid extensive biodiversity loss. Smaller scale clear cuts done in strips or sections, this is called strip harvesting, destroy less contiguous habitat than massive clear cuts and cause less water pollution if uncut buffer zones are left adjacent to bodies of water. This is currently the method of choice in the boreal forests of Canada because it mimics the natural changes this forest is adapted to handle. Canada's boreal forests are dynamic and ever-changing, largely due to natural disasters like fire or insect infestations that open up sections of the forest. These forest openings will be colonized by seedlings from neighboring trees, creating an even-age stand that grows until the next disturbance. Trees and wildlife in these areas are adapted to tolerate this type of forest loss as long as the area cut is not too large and nearby strips or islands of standing trees are left untouched. Moving on, Clear cutting is often ill-advised as it is very damaging to the integrity of most forests. Luckily, it is not the only profitable method available for harvesting timber. Selective harvesting and shelterwood harvesting reduce disruption to the ecosystem while still providing economically valuable forest products. In natural forests, these methods have lower environmental impacts and better long-term yields than clear cuts. In each method, only some trees are harvested. The choice of tree differs between the two methods, leaving behind an area that is still containing trees. Foresters can return to the area to harvest additional trees much more quickly than an area that has been clear-cut, providing steady income in a given forest. These appear to be the most environmentally sound methods for harvesting mixed-age stands of temperate forests. Though many foresters recommend selective harvesting in tropical forests, debates are ongoing about whether commercially viable amounts of timber can be harvested sustainably from these forests. Felling one tree in a tropical forest typically causes others to fall. The forest is densely populated with trees and with vines that connect neighboring trees to one another. Simple steps that reduce damage include cutting vines before felling a tree and cutting the tree in such a way that it hits the fewest neighboring trees when it falls. Strip harvesting in very narrow strips may be a reasonable alternative in some tropical forests. And because soils are thin and fragile in tropical forests, efforts to reduce damage when trees are removed, such as using draft animals instead of trucks, are advised. Ideally, the stand of trees, its health, age, and species composition, and the slope of land determine the harvesting method. Consideration is also given to other species that reside there. When trees are harvested properly, they can provide immediate and long-term economic benefits without serious environmental damage. Even clear cutting can be appropriate when it increases the overall health and viability of a future forest by removing invasive, unhealthy, or genetically inferior trees and replacing them with better stock. Forest management is not without its critics. Conflicting interests make it difficult to achieve a balance between multiple forest uses and ecosystem protection. For example, harvesting trees in the Pacific Northwest provides many jobs, good profits for timber companies, and useful products for homes and businesses, but it can reduce biodiversity and harm salmon runs, which are vital for the ecosystem health, native cultures, and tourism industries. And that brings us to infographic number 5. There are many ways to harvest trees from a forest, each with its own economic and ecological trade-offs. Here are the 3 techniques to evaluate the impact of a particular method. Consider what the area will look like in 50 years after a harvest. And that brings us to key concept number 6. Forests can be protected by encouraging the sustainable harvesting of forest products, finding alternatives to replace wood as a raw material, and promoting the value of intact forests through the realistic valuation of ecosystem services. So funding and technical expertise can facilitate more effective forest management. For example, in 1905, the United States established the National Forest Service. Its first director challenged the prevailing notion that the U.S. forests were inexhaustible and introduced the idea of sustainable forestry, taking only what the forest could sustainably produce or replace. The focus in those early years was maximum sustainable yield, that is, harvesting as much as sustainably possible, but no more, for the greatest economic benefit. In 1960, the United States expanded on this idea and enacted the Multiple-Use Sustained Yield Act, which mandated that national forests be managed in a way that balances a variety of uses, outdoor recreation, and timber interests, as well as the health of watersheds, fish, and wildlife. No single use could predominate. So today, the U.S. National Forest Service, administered by the U.S. Department of Agriculture, oversees 155 national forests and 20 national grasslands and provides guidance for the management of private forests and grasslands, both nationally and internationally. Its overriding objective is the management of these areas in an ecologically sustainable manner and promotes forest ecosystem management as the best way to meet this mandate. Rather than focus exclusively on timber harvests and maximum sustainable yields, the forest ecosystem management aims to manage the forest ecosystem as a whole. This includes a variety of techniques for timber harvesting, vegetation removal, and controlled burns to remove deadwood and stimulate seed germination in fire-adapted species, as well as the restoration of forested areas and forest research. The trade-offs associated with the use of forest resources are the subject of much debate and conflict because each decision impacts both human livelihood and the health of the environment. To be sure, the economic value of wood may be dwarfed by the ecosystem services lost if the area is over-harvested, and protecting the ecosystem may actually prove more profitable, even in the short term. But people still need fuel, building material, and income. One solution, according to a growing number of experts, is to price the ecosystem services themselves. In Costa Rica, for example, higher water bills offset the costs of maintaining rainforests that purify and replenish the water people use every day. This money is given directly to landowners who would otherwise have to chop down the trees to sell as fuel or timber or to convert the land to agriculture. Other options include the promotion and increased availability of sustainable wood products. The Forest Stewardship Council certifies lumber and other timber products through a process that evaluates timber harvesting techniques and the forest itself in terms of wildlife, water, and soil quality. Worldwide, more than 500 million acres of forest are certified by the Forest Stewardship Council as sustainably managed. That's about 5% of the world total. Consideration can also be given to resources such as latex and tree nuts that can be sustainably harvested from standing forests. Alternatives for wood products also exist and can reduce the pressure on forests. For example, lumber from old buildings can be salvaged to provide quality building materials. Paper can be made from old paper, recycled, or from fast-growing crops such as neem, jute, flax, and hemp. Alternative energy sources are also needed in charcoal-dependent places like Haiti. One potential alternative is jatropha, a fast-growing plant whose oil-rich seeds have been hailed as a promising biofuel source. Even the material left after the oil is pressed out can be digested by bacteria to produce biogas, a fuel similar to natural gas. Another option is the production of composite briquettes from a variety of flammable materials such as grass, paper, or sawdust. Shredded plastic can be added to make it more combustible. Reforestation projects are increasing in number around the world. For example, the Kenyan Greenbelt movement has planted and protected more than 50 million trees and has sparked similar movements worldwide. The United Nations Trillion Tree Campaign has planted almost 14 billion trees so far. A unique method of tree planting employed in Myanmar to restore coast mangrove forests deploys seeds from drones. In a year's time, the mangrove seedlings that germinated from these seed missiles grew into 20-inch saplings. This method holds promise with the potential to plant tree seeds much more quickly than can be done by hand in locations difficult to reach by foot. But reforestation efforts take commitment, money, and expertise. In Haiti, the success of reforestation efforts is strongly tied to the availability of water, especially on steep slopes. Engineering terraced water catchment systems to catch and retain rainwater enhances growth and survival of trees. For some, saving the forests may come down to recognizing their intrinsic value, their natural beauty, their inherent sacredness, and their right to exist as living things, regardless of what we humans might extract from them. So this appreciation for the intrinsic value of a forest has been successfully translated into the economic enterprise known as ecotourism. Ecotourism is a viable option for many areas, especially less developed countries. These areas often possess high biodiversity precisely because they are less developed, and they are often found in tropical or subtropical regions with naturally high biodiversity. In the quest to develop economically, these countries may find that the highest economic value for their resources lies in keeping them intact. Ecotourism allows a way for funds to enter the country while protecting the natural areas at the same time. And that brings us to infographic number 6. This table talks about strategies for protecting forests, and it gives an example of those strategies. Please review this table on your own time. And that brings us to our core message for this chapter. Forests have economic value, provide ecosystem services, and have sociocultural benefits. Sustainable forest management may allow the use of forest products while retaining their other benefits. And to summarize this chapter, using sustainable management practices is the key to protecting our forests and the ecosystem services they provide. In Haiti, the reforestation program is working and providing farmers with a sustainable supply of protein and fuel wood. Returning the forest to Haiti will help revitalize the damaged nation.